Now here, we're gonna take the derivative of an integral. They're like inverse operations. So what's gonna happen is the derivative notation is gonna knock out the integral symbol. So here's all that would be left. You'd essentially just be left with the integrand with the dt. So we're gonna be left with 1 over 2 plus t dt. And this is gonna be evaluated from the limits of integration for 1 plus 3x cubed. So really that knocks out the symbol, but all that's left is the integrand along with the integration limits, which go here. Now do the usual routine, but watch what happens. This here gets plugged in for t. So this is gonna equal 1 over 2 plus, and then you plug that in for t, which is 1 plus 3x cubed. And then multiplication, because there should be a multiplication symbol. Then you have to multiply by dt, the derivative of the number that you plugged in. So the derivative of this would be, of course, 9x squared. So that's the top part being plugged in. And then, the usual would be minus. And now you plug in 4 into t. So that'd be 1 over 2 plus 4 times the derivative of whatever it is that you're plugging in, which in this case is just 0, because that's the derivative of a constant. 0 times that is just 0, so it's irrelevant. And so all you're left with is 9x squared in the top. Underneath, 2 plus 1 is 3 plus 3x cubed. You can actually reduce every term by 3. And it appears as though this would be the final result. So when you take the derivative of an integral, dismiss those notations, and you plug in the limits of integration. And if one of them happens to be a constant, the derivative of which is 0, that means that this can essentially be dismissed because of that 0, which is bound to happen. And I might have missed some notation, some technical notation in here, but I guarantee you one thing, that's the answer. Down here, the same thing. The derivative knocks out the integral, so all you're left with is secant t dt, but we're gonna evaluate it from x to x squared. So now plug in x squared in for t, so that'll be secant of x squared times 2x, because that's the derivative of what we just plugged in, minus secant of, we'll plug in x for t, times 1, because that's the derivative of x. And to clean this up, 2x secant x squared minus secant. Nothing really happens. I guess if you want to, you can factorize a secant. It's not really going to change matters much at all. Actually, you cannot factor out a secant because that's secant of x squared. So really, just leave it like this. Okay. And let's see. So let's keep going here. So now number 5. So we have an integral, and let's just go term by term integration. And again, I'll just go a little faster this time. So integral, integrate, term by term. So that'll be 1/4 x to the 4th minus 2/3 x cubed plus 2x squared. If you do term by term integration from -1 to 1. If you plug in 1 into all the x's, you'll eventually end up with 1/4 minus 2/3 plus 2. And then minus, and I'll plug in -1, there, and there. You will end up with this here. And then things should eliminate. Let's see, what goes away? The 1/4 knocks out the -1/4. The 2 knocks out the 2. So we're left with -2/3 minus 2/3, which is -4/3. Final answer. Here, some people would make a use substitution, which you can't, but I'm just going to distribute. Because instead of having 2 factors, I'm going to have 1 factor by simply distributing and expanding the terms. Now I can just treat this like I did this problem, right? If you want to make a use substitution where u equals x squared minus 3 and du equals 2x dx, you can do that. That's fine. You're going to get the same answer. I choose to make my life easier by just distributing and doing term by term integration. And so if you do integrate term by term, I believe that this is what you should get, right? Because the derivative of this would be that, and the derivative of this would be that. Looks good, and really just put a plus c and we're done, because this was indefinite and this was definite. And let's see here, this is definitely a u substitution, because I recognize that the derivative of this can be made to look like that. So here, I'm gonna let u equal 1 plus 6t squared. Now my du, the derivative of this would be 12t dt. So the dt matches there, but that says 3t and this says 12t. So what I'm going to do is I'm going to divide both sides by 4, because this will be 1/4 du, and this division by 4 turns it into 3t dt. It's a tongue twister. And then it matches perfectly. So now I can rewrite this in terms of u and du. So I have my integral, and replacing 3t dt would be 1/4 du. And I choose to put the quarter in the front and the du in the back. Now what would be left? There's just a 1 up there. And then it's a square root of this, but this is u. So it's the square root of u. And temporarily, I'll ignore the limits of integration. So now what I'll do is this. 1/4 integral. This is 1 over u to the 1/2 power. So this is u to the negative 1/2 if you bring it upstairs. And I'll follow your definitions of integration, like the power rule or the reverse power rule or whatever it's called. You add 1 and you divide by the new power, right? You add 1 to this and divide by that new power. This will be 1/4. That'll be u to the 1/2 over 1/2. So that's 1/4. Dividing by 1/2 is the same as multiplying by 2. And so now 2 can interact with the quarter to give us 1/2 square root of u. But we know what u is. U is that there. So this is 1/2 square root of u, which is 1 plus 6t squared. And now we can evaluate this from the original limits of integration, from 0 to 4. So if you plug in 4 here, that'll be 1/2 times the square root of, what is that, 97? That's weird, but whatever. And then minus, now plug in 0, it'll be 1/2 times the square root of 1. So this is just 1/2 square root 97 minus 1/2. If you want to factor out a 1/2, that's fine. This is what you get. Now this one here, yeah, another u substitution. So the u would be z squared minus 5. And the du would be 2z dz. So I see a z dz, but not a 2. So I'm going to divide the 2 into the other side and turn it into a 1/2. And now everything can be replaced. Z dz gets replaced by this. That gets replaced by that. So this would be, let's see, so this is a square root of u. And then we said z dz gets replaced by 1/2. There's your 1/2 du. So let's see, so this is 1/2. This is u to the 1/2 du. And now do the same thing as we did in the previous problem, like that power rule, but in reverse. You add 1 to the power and divide by the new power. So this is u to the 3/2 over 3/2. So now we can multiply by the reciprocal instead. That would be 2/3, u to the 3/2 into 3/2. And then this is going to be 1/3, and this would be u to the 3/2. That's the same as 1/3, the square root of u cubed, right? Just changing the notation. And we can bring back the u's. So this is 1/3 square root of, instead of u, drop in what it equaled originally with the power of 3, and go ahead and put a plus constant.